Very good. And you will talk about norms compliance, please.
Okay. Thank you. Can you hear me? I hope it's okay for you. Yeah. So good afternoon, everybody. I would like to thank Katarina for the introduction to my presentation, because I will be speaking about prisoner's dilemma as well. I will follow up with the more application of this model to the question of which is related to social science, which is norms compliance, and I will back to the more easier model of prisoner's dilemma when I consider it as the question order effect. So the content of my presentation will be, I will say something about the norm compliance from the perspective of social science. Then I will present really briefly quantum model of decision making, and I will show you my experiment in prisoner's dilemma game with completely new results, and I will make some conclusion relating to the social science. So, what do we do about norm compliance? We know that in society we have social norms that are informal rules that govern the behavior of members of the society, and there are three broad theories. How do we explain why the people follow them? One is the theory of socialized actor, one is a concept of group norms, and probably the most influential is social choice theory, which is based on game theory. And I will apply this problem to the case of prisoner's dilemma game, and I would like to try to answer the question, why are we able to cooperate with the stranger, and if so, do we comply with the cooperative norm in this game? So, we have some empirical findings from the sociologists, which are pretty interesting, that the existence of the norm itself does not lead to the compliance with the norm. And there are two different expectations that influence our choice to obey the norm. And one of them is so-called empirical expectation, which is what we expect others to do in the situation, and the other is normative expectation, and it is about what we believe others think we ought to do. So their expectation toward us. So there are these two kinds of expectation, and I would like to model them in the quantum model. But what are the standard solutions? For the standard solution, the social norms are basically either Nash equilibrium of the respective game, or the equilibrium of the coordination game, or some kind of choreographer of the particular epistemic game. These all are the approaches which are based on the game theory. But all these approaches differ in important aspects, but share the same basic assumption, which is Bayesian rationality of the players. And as Katarina was talking about, we know that there are some effects which contradicts the standard logic of Commutatorian theory. So we know, you have seen this table from Katarina, that the people usually produce something what's called disjunction effect, which is the violation of sure-thing principle in the prisoner's dilemma game. So the standard explanation for these fallacies, cognitive, is that it's some kind of biased rationality of the players, or the authors, for example, Gintis, use the canon heuristics to explain these effects. And then we have alternative for these, which are the quantum models of cognition and decision making. We have Tesař here, which is one of the authors of these models. And I would like to answer the question if the quantum model is able to explain the known features of the social norm compliance. That means the empirical and normative expectation in this game. So I will really briefly present the quantum model. And I have to warn you that this is the kind of presentation for social scientists or political scientists. So I name it only the quantum toy model, because I present it above the realm of real numbers. because it's easier for them to grasp. So I will present it here this way. So what's important in the quantum model that I look at it as the like question order effect. So I have two different questions I can ask the player. One is, what are you going to play? What is your strategy? And the second one is, what do you think your opponent is going to play? So what are your expectations about your opponent? And so there are two variables of the game, player strategies and player's expectation towards the opponent, and they both are two possible outputs, cooperation and affection. And one is the decision-making in self-perspective, and the other one is the decision-making in the other perspective. So there are two possible models, at least from my point of view. We have two-dimensional model that these two perspectives are incompatible. So we have basis C and E and C prime and D prime. Or we have the four-dimensional model where we expect that the player is able to make like higher representation of the game and use the tensor product of these two, like cooperation and expected cooperation from the opponent and so on. So there are two possible models. I will present briefly the two-dimensional model. So I said that it's in the above the realm of real numbers. So it's explained the presence of the angles, alpha, beta, and gamma. So here you see the initial position of the player in the game and two perspectives which are moved to according to the angle beta towards each other. And you have two possible, as Katarina explains here, the player, for example, to reach the combination of his cooperation and the opponent's defection, which is D prime or C. He or she has two possible ways how to reach it, to decide in her or self-perspective, and then in the other perspective or the other way around. And I wouldn't agree that we are not able to make predictions from this model. The standard solution is to insert some parameters and to fit them to the data. But I'm sure there are three kinds of prediction we have from this model already. First one, we know that there is the disjunction effect in the data, and it directly flows from the presence of the disjunction effect is that we have to have the order effect among the sequential probabilities. And it has never been measured in the experiment before. So this is the first prediction, which is qualitative, but is the prediction of the model. If the disjunction effect is present, then order effect is present, should be present in the data. So this is the first prediction. Second one is the Q test of Busemeyer and Brusa, which I cannot explain here in more details, but you can, if you use this model, you can find out this explanation, which has to hold for all the applications. And it has been shown that it holds for all kinds of order effects or the question order effects. So it's the quantitative prediction. And last prediction, which is model specific, is that in the two-dimensional model, the conditional probabilities should be equal because it follows from the symmetry of the projection of one axis to the other. So there are, from the presence of this disjunction effect, we can make three predictions. One is qualitative, one is quantitative, and one is model specific. And back to the question of the social norm compliance. This is the a slide for my guys from political science. Is that we have these three angles, alpha, beta, and gamma, And alpha relates to the willingness of the player to cooperate, because yeah, you can see it, I'm pretty sure. Gamma is related to willingness to expect the cooperation from the opponent, and beta is related to the willingness to follow the expected strategy of the opponent. So beta is related to the normative expectation, gamma to the empirical expectation of the social norm compliance. And if I just plot this graph for some concrete value of alpha, so we have the blue line is the level of cooperation of the player, is like any number, and if you plot the level of willingness to cooperate of the opponent, then you can see how is the effect of how the player is willing to cooperate after considering the perspective of the opponent. And you see that there are 4 broad regions in the graph, that for betas bigger than 0 to here to 40, the players expected that their opponent are going to be more cooperative, and they follow them. So there's like cooperative norm at play here. For the betas below 0, we have the selfish norm, because the players expected others to be more selfish, and they follow them if they consider their choice before they own. And there are 2 funny regions on the right, when we have opponent which is pretty willing to cooperate, and he believes that his opponent is going to cooperate as well, or is more willing to cooperate, and it leads to the instead of this, he is going to be more defective, and it's because the perspective so far from each other that it's make this effect. But I would say from the perspective of the social science, we expected beta near 0, because we don't expect that our perspective and our expectation about the others is so different. So there's also either cooperative norm or selfish norm present in the prisoner's dilemma game. So that was the connection of the model and compliance with the social norms. And I will present the results of the prisoner's dilemma game, which is the experiment I've done last year in Ohio. Why we need a new experiment? Because we know there are several studies which presented disjunction effect in the prisoner's dilemma game, but never has tested the opposite order of questions. So I simply ask, if I measure this, do we see the effects which is predicted by the quantum model of question order effects? Yeah. So the strategy was, the treatment was that I asked first treatment was that I put the self-perspective first. So I asked the player, what is your strategy to play in the game? Yeah. And then I ask, what do you think about your opponent? And the second treatment is, what do you think about your opponent and what are you going to play? So, some details about the experiment, but it's not so important. But what's important is results. So I said that there is the disjunction effect among the data in the prisoner's dilemma game. So this is only the replication of the previous studies. My participants were really cooperative, 65% of them cooperated in the game, but they only expected cooperation in 40% of the games. And there is the really big, I cannot show you, but there is really big interference effect, which is 23%, that the players are going to cooperate in 65% of plays, but it goes down to 42 if they consider the opponent before that. So there is really big interference effect. And as I said, it predicts the presence of the order effect. And if you see in the data, you have the sequential probabilities. The blue one is self-perspective first, the orange one is the other perspective first, and you can see or read in the paper that there's also the order effect in these sequential probabilities. And what's really important, that there is the Q-test that holds for the data, so that the matching strategies in both orderings are above the same level of 65%. Yeah. So the quantitative predictions of Buzeman and Broza holds as well. And the last question, it's really, it startled me at most from the data that the last prediction was about the symmetry of choices, if the conditional probabilities are the same in both orderings. And if you cannot probably see it from the graph, but it's not exactly the same. But if you control for the sex of the participants, it shows up that men really violates this kind of prediction, but women really follow the quantum 2D model. So this, I didn't expect it before the experiment, but it is in the data. So, and it's consistent with Alexander Venn's claim that if a quantum man is something, then it is a woman. So,
P of D, condition D prime means in words, remind me?
What's the which one?
P, the big anomaly, P of D given D prime.
The last one.
Yes.
It means what's the probability of defection after you choose expected the defection of your opponent.
Expected the other one to defect.
Yeah. So, and it should be in the 2D model. It should be the same for all these probabilities, but it holds only for women. And the conclusion, so almost on the time. So the conclusion is that the analysis shows that the quantum model is pretty simple quantum model is explained to known patterns of interaction between the player and his expectation about the others. The quantum model in my experiment at least was accurate in all three predictions, one qualitative, one quantitative, one model specific, and it explained the known fallacies of the PD game. And the startling result, for me at least, is that women and men represents the game differently. Women are closer to the two-dimensional model and men to the four-dimensional model. And for women, the PD game is like sequential measurement of two mutually incompatible perspectives, but men use the 4D representation of the game. For them, the strategies and expectation are compatible. So it's like the quantum explanation of that. And what's really starting for me is that there, according to my analysis, is that there is the selfish norm, social norm, and plays, because players expect significantly lower cooperation from the others, which is the empirical expectation, and they follow it because the perspectives are close enough to support that. So it's the normative expectation. And these results, as I see it, are at odds with the standard interpretation of the PD game, which see rational players as selfish and the social norm as a tool that enables them to be more cooperative. But I argue that the opposite is true, that the players by themselves, in the self-perspective, are rather cooperative, and it is their expectation of selfish others that makes them selfish. And but it is conditioned by taking others into account. So if they don't think about the others before they decision, there is no such effect, but they are pretty cooperative without that. So that's all. Thank you.
Thank you. We have a bit of time for a couple of questions, comments, remarks.
So, could you go back to the slide where you actually give the details of the setup of the experiment? Because as has been already discussed, it's very important. For example, when you say the last statement, when people don't think about the other, they are cooperative. When they, of course, this sentence, if you think about it, doesn't make sense because any one thing. I mean, so we are essentially assuming that people are stupid. They think first order, right? So what you mean, I suppose, is when you elicit, you frame their mind, and that's what I would like to be informed on how you specifically frame the state of mind of the decision maker. Because if you are a little bit, it depends also on the setup, how much time you give people to make decisions. Is it like a, or is it, what is the incentive, what is the stake, and so on. And all this is very important. So can you give us one minute description of this?
Yeah, I've run 2 rounds of this study. One, like a pilot study with the students at the Ohio State University, and second round was online through the Amazon Mechanical Turk with that number of participants. There was real money at stake. They played $4 for dollars, and the players played against the unknown opponent, so they don't know any information about the opponent, and it was between groups design. So I put some group self-perspective first and other group other perspective.
They have to make decisions?
Whatever time they wanted. It wasn't restricted.
And I suppose they were all from Bangladesh?
No, they were from Midwest US, so Ohio, Chicago, a small region, because you can constrain it in mechanical terms. So I constricted for Ohio and neighborhood states. I had one guy from India, but it was through some proxy. Yeah, and what's the?
How do you elicit?
It's a really important question, because in the quantum model, you can say that they are thinking about the others, even if you ask them of their own strategy. But the quantum model consider the 2D model consider as non-compatible perspectives, so they cannot answer both at the same time. So they can need to choose, and if you ask them, okay, what is your strategy, then they cannot be sure about their expectation about the others. It's the nature of the quantum model. And I elicit the thinking about the others, that I asked okay, what do you think the others are going to play? And they were incentivized by $1 if they guess correctly. So it was
So this is a question before they make the decision?
Yeah, I asked half of them what do you expect from the others before, and half of them after that. So this was my treatment. And this was
I have just a very small comment. So I would not be so completely sure that the disjunction effect can only explain. Sorry? Louder. I would not be so sure that the only explanation for the disjunction effect is question orders. So there are other explanations are possible, and they are compatible with what the experimental data and the theoretical framework. Nevertheless, of course, this is quite reasonable.
If I can react, I saw this as the most simple model for this kind of question, and it has never been tested before in this experimental design. So this was my simple model and experimental design that can test it. So I did it and it worked. So that's my reason why I stayed with the simple model.
Okay, let's take the speaker again.